you have to end up with a closed path here. Now I want effective resistance. Okay, let me change terminal. First AB will start. I want effective resistance across RAB. Find RAB. One by one we'll find out. What do you mean by RAB? Means you directly you begin like this. So you consider a cell. You connect a cell. This is only for your understanding purpose. Huh? There's no cell. So the cell will send a current I. So what will happen to this current now? How to say they are series parallel? By taking up of branching of currents. So this current when it comes, it will branch out like this. I1, I2, and I3. So branch it like this. This I1 remains same, no? The same current I1 flows. So with this, what you can conclude now? These two are in series. So this I1 now, this I2 they'll combine. So here how much we'll get? I1 plus I2, then I3. So how much of current entered, how much of current left the positive terminal, that much of current should leave, that much of current, how much of current left positive terminal of cell, no? That much should enter the negative terminal. Any reason? Anybody? Why I should do like this? What is the current? Rate of flow of charge? No, charge should be conserved, no? What do you mean by current? 10 ampere. What do you mean by that? Some amount of charge is leaving the positive terminal of cell per second. That much of charge per second should enter the negative terminal. No? Then only charge must be conserved, because you take any device, charge should be conserved here. So I'm applying KCL. What is the current entering I? So how much of leaving? I1, I2, I3. You can see here, current I1 will enter. Then how much of current will leave? I1, I2, and I3. Then how much of current should enter junction B? I3, I1 plus I2. Then how much should leave? I. So current entering a junction should be equal to current leaving a junction. And the cell, current I will leave positive terminal. Then current I should enter. So like this open. So we have to take care about conservation of charge principle. Okay, from this I'll simplify the network. This was a cell. And the cell is just brought for our convenient. And now you come for the simplification of network. This is as it is 3 ohm. This is 1 ohm. And this 1 ohm. This 4 ohm plus 2 ohm is how much? 6 ohm. Will become like this, 6 ohm. Now again you push that same current I. Okay, this current I. So this will be now what will happen? Will branch out now. So this will be I1. Okay, now how I1, I2 are there? This current is branching now. How the 6 ohm and 1 ohm, they're in parallel. So effective resistance. So 6 ohm, 1 ohm. So this will be 6 by 7 ohm. So this should be a 1 ohm. Okay, now again the same current I1 plus I2. So this will be current here. There's a first problem I'm showing in detail. So how much of current here it will be? I1 plus I2. And what is the current here? This should be I. How 6 by 7 and 1, they are in series. The next circuit will be 3 ohm. So this will be 13 by 7 ohm. How these two are parallel? Because the current will branch out, no? If you take this current is branching, so they're parallel. So that the effective resistance will be RAB should be equal to, I'll write one more circuit. What is RAB? You can write it now. RAB should be equal to 13 by 7 into 3 by 13 by 7 plus 3. Anybody value? 39.
39 by 34.
This should be the effective resistance as seen. And similarly, I want RBC or RAD will calculate. Find there's the first one. Next, I'll show one more. Find RAD. RAD means, so what you should do, you should connect the cell should be connected across this one RAD. So here the cell should be brought. D. Now first from where you should simplify? You should come from ABC. Yeah? Look at the path ABC. First what happened, you have to look at this. These two are in series, no? Because if any current flows in this branch, the same current will flow here. These two are in series. So instead of drawing so many nodes, directly looking at the diagram, try to simplify here. So this will be or one. This is a terminal. So the next circuit will be this 4 ohm. You should not disturb it. These two are 4 ohm. Where first you have to look at the branch. ABC branch is what? You have to look at here. Then after this, this 4 ohm, they're parallel, no? 4 ohm and 1 ohm, they're parallel. These two are parallel. This 4 ohm and this 1 ohm, they're parallel. Effective will be 4 by 5 ohm. This will be 2 ohm, 4 ohm. So this will be 4 by 5 ohm. Now any current flows through this branch. Any current flows here. Now you see this. The current which is entering at A, so will pass through C and this one. So how this 2 ohm and 4 by 5 ohm, they're in series. No, the same current will pass through them. So the effective circuit will be now 4 ohm. They're in series. So 5 to 10, 14 by 5 ohm. Now how these two are, they're in parallel. So this is AD. So what is RAD should be equal to? RAD should be equal to 14 by 5 into 4 by 14 by 5 plus 4.
56 by 34.
56 by
28 by 17.
Some different answers.
If we simplify this, will do.
56 by
34.
okay, it will not have same
34, sir.
34. I think this can be further 2.
Yes, sir.
20, 56, 28 will come. 28 by 17. 28 by 17. Like this, we can find out effective resistance across any 2 points. B, C, C, D. It can be determined. So there's a one, how to identify series parallel. So what you should do, across the terminals where you are finding out the resistance. So from there, you have to introduce a cell and you have to push a current. completed. So I'll go for other things you can work out. RAC. So similarly, you find out RAC, then RBC, then RCB. These things you try to find out. So there's a method of identifying they are in series and parallel.